In practice exercise 2.9, we're told that a standard aspirin tablet contains 325 milligrams of aspirin, which has the molecular formula C9H8O4. We're asked to determine how many moles and molecules of aspirin are in one tablet. So the first thing I want to do is collect and organize my information. I always like to write out where I'm starting, which is the given, and we're told that we have 325 milligrams of aspirin, and we're also told the chemical formula of aspirin, C9H8O4. Now, in this problem, we want two things, moles and number of molecules. And I'm just going to focus on one thing at a time. I'm going to focus first on moles, not only because it was given first in the formula in the question, but I know exactly how to get from mass to moles, and that is the molar mass. Now, the first thing I need to do anytime I'm going between mass and moles or moles and mass, and I need a molar mass, is I have to calculate the molar mass. So we know by now that we get the molar mass of each element from the periodic table, and carbon has a molar mass of 12.01 grams per mole, hydrogen 1.01 grams per mole, and oxygen 16 grams per mole. And again, I'm rounding to the nearest hundredth. So to calculate the molar mass, I know that I have 9 carbons in 1 mole of aspirin, so I multiply 9 by the molar mass of carbon, 12.01 grams, to get 108.09 grams. In 1 mole of aspirin, there are 8 moles of hydrogen, so I multiply 8 by 1.01 grams of hydrogen to get 8.08 grams. And in 1 mole of aspirin, there are 4 moles of oxygen. So 4 multiplied by the molar mass of oxygen of 16 grams is 64.00 grams. When I sum these together, I get 180.09. So here's the molar mass of aspirin. 1 mole of C9H804 is equal to 180.09 C9H8O4. So I'm going to do a double unit check now. I'm going to look at what I am given and what I want, and my conversion factor makes sure I have 2 of every unit. So I'm given milligrams of aspirin, but I don't have milligrams in my conversion factor. I just have grams. So I know I'm going to have another conversion factor that gets me from milligrams and grams. And in my conversion factor, I have mole of aspirin and I want mole. So I have 2 units of moles, but not 2 units of milligrams or 2 units of grams. So I know that I can write a prefixed metric conversion factor with any base metric. Let's see, that sounded really awkward. I can write a conversion factor between any prefix unit and its base unit. And milligram is the prefix unit and gram is the base unit. So 1 equals 1, gram equals gram, and milli equals 10 to the minus 3. So after I write out this conversion factor, 1 milligram is 1 times 10 to the minus 3, then I have 2 of every unit. I have 2 milligrams, I have 2 grams, and I have 2 moles. So the first thing I want to do is convert my milligrams to grams. So I have milligrams, what I'm given, milligrams goes in the denominator. Those units cancel out, and when I multiply 325 by 1 times 10 to the minus 3, I get 0.325 grams. Now I want to convert this mass to moles, and here are grams, and so the grams of my molar mass needs to go in my denominator. Gram divided by gram will cancel out, and when I divide 0.325 by 180.09, I get 0.0018047. Now the units are going to be moles because my moles have not canceled out. And since I'm given 3 sig figs, I want to express my final answer in 3 sig figs. And does this make sense? Well, a mole of aspirin is 180, almost 200 grams. And the sample that I'm looking at is much, much less than 200 grams. So this answer absolutely does make sense. If I had 200 grams, a tenth of it would be 20 grams, a hundredth of it would be 2 grams, and a thousandth of it would be 0.2 grams. So this is close to 1,000th of 0.2 grams, and that makes sense. The next part of my problem asks for number of molecules. Well, I know that if I have moles, I can always get to molecules. So I'm going to take my answer from the last part, 1.8 times 10 to the minus 3 moles of aspirin, and I'm going to use that to get number of molecules. The conversion factor between moles and number of particles is always Avogadro's number. So 1 mole of aspirin, C9H8O4, is equal to 6.022 times 10 to the 23 molecules of C9H8O4. So my given is going to be my moles, and I carelessly forgot to write moles here. And I want to take the time to write moles, because if I don't know what my units are here, how do I know what units to put in the denominator? So I have moles of aspirin in my numerator, so moles of aspirin go in my denominator. My moles cancel out, and I'm left with units of molecules, which is what I want. So when I multiply 1.8 times 10 to the minus 3 by 6.022 times 10 to the 23, the numerical value I get is 1.084 times 10 to the 21 molecules. And since my given value has 3 sig figs, I'll express this final answer with 3 sig figs and round 1.084 to 3 sig figs, 1.08. Now, does this answer make sense? 10 to the 21 molecules. Well, 10 to the 21 is 2 place values less than 23, and yes, that makes sense, because if this was about 2, 1.8 is 2, 2 times 6 would be about 12, and when I look at my power 10s, when I multiply, I have to add them. So my final answer would be on the order of magnitude of 12 times 10 to the 20, because negative 3 plus 23 is 20. And then if I put that in scientific notation, I make this value smaller, so I've got to make this value larger. So 10 to the 21 may